So in the previous tutorial, we have discussed about the concept of stacks. In this tutorial, we are going to implement the stacks in C++ language, and we are going to implement these two main functions, which is the push function and a pop function. Push function is used to push an element into the stack, and pop function is used to just pop out an element from the stack. So basically we can implement stacks using an array, and we can also implement stack using a linked list. So in this tutorial we will focus on the array implementation of stacks, and in the next tutorial we will focus on the linked list implementation. So the very first thing that we need to remember in both of these functions are the check statements. So I'm going to write here the check statements. So the first check statement, before just moving to the check statement, we will see a variable. We know that the insertion and the deletion, or the push or the pop function, take place at the same end. So we are going to maintain a variable by the name top, and we will we will use these functions push and pop on this top variable, and this top variable will store the positions, or you can say the index of the stack. So let's suppose this is our stack. Initially the value of top will be -1. -1 indicates that the stack is empty, and this value top will increase as we go on pushing the elements into the stack. And so I'm going to write here push. So if we are pushing an element into the stack, then the value of top will increase by 1. So I'm writing here +1. In case of the pop function, the value of top will decrease by 1, because after every element after every pop function, an element will come out of the stack, and thus we will just decrease the value of the top, and we will use this top variable to traverse and display all the elements of the stack. So the condition in case of the pop and the push statements are like this. So there is an if statement, and if the value of the top is greater than, if it is equal, if it is not equal to max size. And max size is a variable that stores the number of elements that can be inserted inside the stack. For example, let's say we are creating an array with the name stack, and this contains the integer elements, and let's suppose this has 10 as a parameter, you can say, and it has 10 elements. So the maximum size of this stack will be 10. So if the value of top will be equal to this value, it means that you cannot push any more elements in it, because the size is limited to 10. So this condition is known as the overflow condition, and this means that our stack is full. So we are going to we will just display the data of our stack if this statement evaluates to be true. So if top is not equal to maximum size, we will display the data, else we will display that the stack is full and thus overflow, or we can say the stack overflow. So this is the check statement of the push function. If the value of the top variable is equal to the maximum size, or you can say the maximum number of elements that a stack can accommodate will be equal. So the condition is known as the overflow condition. So this means that if top will be equal to maximum size, you cannot push an element into the stack. In case of the pop function, you cannot pop an element from the stack if the stack is already empty. So the check statement will be if top is equal to -1, this means that our stack is empty. So this condition is known as the underflow condition. So this is known as the stack underflow condition. And in case of stack underflow condition, you cannot pop out an element from the stack because the stack is already empty. And this is the main reason why we are using this top variable here. So let's now move to our CLine IDE and implement this whole stack. So the first thing that we are going to do is we are going to make some function call in the push function. So we are going to make more than 2 or 3 function calls. So this will push the elements in the stack. So let's suppose I want to insert 4 elements into the stack. So I will create 4 push functions. And let's suppose these are the elements of the stack. And the 4th element is, let's suppose 8. So we want to push these elements into the stack. So these are just the function calls. Here we are going to create some variables. The first variable is the max size, and max size is the number of elements that our stack can accommodate. And then we are going to create a variable, we are going to create an array of 10 elements. And next we are going to create the variable top, and initially the value of top will be assigned as -1 because the value of because initially the stack will be empty. So I'm going to write initially stack is empty. So now what we're going to do is we're going to write the whole push function, and since push function is not going to return anything, we're just going to write it as void. And then since push function is accepting an integer value, we're going to write int, and we're going to assign the data here. So let's now just write the check statement of the push function. So the check statement says that if the value of top is equals to max size, then we are going to display that it is a condition of stack overflow. Else, what we will do is, in the push function, there are 2 steps to do. First, we will have to assign the value to the stack. So this data should be assigned to the stack. Before doing that, we will have to increment the value of top by 1. So you can see here that in the push function, we have to increase the value of top. So since initially the value of top was -1, so after first call of this push function, the value of top will become 0. So the first thing that we will have to do in the push function, first step is to write this statement, top equals top plus 1, or you can even write plus plus top. So after incrementing the value of top, we are going to assign the data at this top position, because we know that the insertion and the push takes place at the top position, and we will assign this data to this top position. So this is what we are going to do in the push function. So I'm going to write here top equals top plus 1. Alternatively, you can also write plus plus top. So it increments the value of top by 1 because now we want to insert a new element in the stack. And we will have to make sure that this top value does not increase or does not overflow after this maximum size, that is 10 in our case. And after incrementing the top value, we will assign the data that is passed at the time of function call to this push function, and we will assign it to the stack top position. So after the first call, you can see that this is the first push function call. We are pushing 3 to the stack, and you can see that initially the value of top was -1. When we will call this function push, the value of top will get increased by 1 and it will become 0, and the stack, so the top will get replaced by 0. So the 0th index of the stack will be assigned the data, which is 3. So stack 0 becomes equal to 3, and this goes on and on. So you can insert as many elements as you want. So the next function is the pop function, and what we are going to do is we will just pop out an element from the stack, and we will also display that. So we will write a while loop for that case, and we will run that while loop until and unless this condition evaluates to be true. So let's now implement the pop function now. So first of all, we are going to write the while statement. So the condition in the while statement should be if the value of top, this while loop should run until and unless the value of top becomes equal to -1. So this should be not equal to. So this while loop will run until and unless the value of top becomes -1. So whenever the value of top becomes -1, this means that the stack is now empty and you can no more pop out an element from the stack. And this condition, we know that this condition is the stack underflow condition. So the pop function will not accept any parameter. It will not pass any parameter because we are just popping out an element. So this is the pop function, but this pop function will return the element which is being popped out from the stack. So we will assign that in the data field. So this pop function will just return an integer variable, or you can say the integer data of the element that is being popped out from the stack. So let's now write the pop function. Since our pop function is returning an integer value, we are going to write it as int pop. And first of all, since we are already checking this that the top value is not equal to -1, but we will write here again the text statement because we want to make it sure that the pop does not take place if the value of top equals to -1. So if the value of top is -1, we are going to display that this is a stack underflow condition. So else, in the else part, what we are going to do is, first thing, we will just decrease the value of top by 1, and before decreasing the value of top by 1, we will just assign the value of the stack top position to this data field. So our data becomes equal to the top position of the stack. So this stack top will return the element at the top position, and the value will get stored in this data field. And after this, since you can see that there are two statements, we will have to use the curly braces here, and this should be placed here. So this is now the else part of this if, and in this case what we are just doing, we are assigning the top element of the stack to this variable data, and then we will just decrement the value of top by 1, and in this way the pop function takes place, and finally we will return the data. So this data, when this function will be called, it will first check this condition, then it will assign the element at the top position to this data field, it will decrement the value of top by 1, and then it will return the data. And then in this while loop we will display this data. So this is our whole implementation of the stack, and let's now just run this program and see the output of this program. So you can see the output here. So you can see that the first element pushed in our stack is 3, then 5, then 7, then 8. So I'm going to draw the corresponding stack for these 4 push calls. So the stack contains 4 elements, 1, 2, 3 and 4. So these are the 4 elements of the stack, and the first value will be 3. So initially the top value was equal to -1, and now it will become equal to 0 after inserting 3. Then we are inserting 5, then 7 and then 8. So when we will add 5, the value of top will increase to 1, and then we will insert the value 7 and then 8, and we will increase the value of top like this. So you can see that this is now the stack after we have committed all the push functions. So when we want to pop out the elements of the stack, we can see that the value of top is 3 now. So this is the top of the stack, and since we are inserting at the top position, we are also going to pop out from this top position. So the first element to be popped out will become 8, then 7 will be popped out, then 5 and then 3. So this is the main concept and the main idea behind stacks. So in this implementation we have used arrays. In the next tutorial we are going to use linked list, and we will implement stacks using linked list, and we will see the difference between using array and linked list in the next tutorial. So thanks for watching.